Okay, this is going to be lesson 3 in the rationals unit. We're going to find the equations given the characteristics. Okay, it says vertical asymptote at x equals -3 and a horizontal asymptote at y equals 0. So a vertical asymptote at x equals -3 would mean that it would have to be x plus 3 in the bottom. All right, how would you have to have an asymptote of 0? Well, that's got to be a 1 there, okay? Now, the removable discontinuity means that's a hole. So in order to get this, I would have had to eliminate this times this, okay, right, to cross off. So my top part would be this. The bottom part would be, if I multiplied that out, would be x squared minus 7x minus 30, okay? All right? I would be willing to accept this or this as the answer, okay? Either one is acceptable, okay? A vertical asymptote at x plus 8, well, what would that come from? X minus 8 being down there. A horizontal asymptote of 5, okay? So if I'm getting that, all right, that means that I have to have 5x plus something. I'm just going to say plus 2. Why? Because 5 divided by 1 would be 5. All right? A removable discontinuity at 1. So this is what I'd have to have here. So my function would be 5x plus 2 times x plus 1. Okay? Over x minus 1, x plus 1. If you multiplied that out, okay, that would be 5x squared plus 7x plus 2. All over x squared minus 7x minus 8. Either answer would be acceptable. Okay, all right. So hopefully you saw that. Okay, so I would have started with x minus 8. Okay, all right. Because the horizontal's got to be 5, that's got to be 5. I can put any number there that I want. All right, the removable x plus 1, so I could have that, or if I multiplied that out, that's what I would get. Okay, all right, find the rational. A vertical asymptote at 7, so that'd have to be that. A horizontal asymptote at -5. Okay, so there's a couple options. I could put that as -5x plus 3, because that would be a tie, or I could have the option of, all right, 1 over x minus 7 minus 5. So either one would be acceptable. Okay, all right? Because both of those, when it's all said and done, would give me those two things. All right? All right, so why don't you guys try these 3 on your own? The way I'll check this is that I'll check what your final answer is, whether that would work. Okay? All right, now let's look at it from a graph standpoint. What I want to do is identify the vertical asymptote. All right, so that's at x equals 3. This dashed line is at y, and the horizontal asymptote is y equals 2. And in this case, I do not have any removable discontinuities, okay? So a couple of different ways I could write that. Okay, I could write that as x minus 3, and this could be like 2x plus 1. All right, I'm not really, all I want to do is check the asymptotes. I'm not so much concerned about the intercepts there. So that would work, or I could have 1 over x minus 3 plus 2. That would also work, something of that nature. All right? Okay, now I've got a vertical asymptote at x equals 2. I've got a horizontal asymptote at y equals 0. And then I got a removable or a hole at x equals -4. Okay, so this would be x minus 2 with a 1. That's the only way I could get that. A hole of x plus, would have to be that. So I can either get this, or if you wanted to multiply that out, that's x plus 4 over x squared plus 2x minus 8. Either answer would be acceptable. So you just want to identify what you got there. Okay? All right, now, if I look at this one, I say, Mr. Evans, what do we do with this one? This one doesn't have any asymptotes, but it does have a hole. where would that hole be? Okay, well that hole is at 6, okay, all right. Now, what would that mean? That would mean that I have this, okay. Now, the only way I can get that line is I look at the slope that's up 1, 2, 3 over 1, 2, 3, okay, so that's 3 over 3, which is 1. It's passing at 3, so that's this. So this would be my equation, because that would eliminate, that's there, and there's my hole. Okay, all right, let's do one more of those. All right, let's say I had, so, boom. Let's say I had something like this. Okay, all right, so what would happen there, all right, there's a hole here at -1. So I would know that that would cross off. Now, the remaining part is the slope, which is up 2 over 1, so that's 2. So y equals 2, and then it crosses at 1, so that'd be 2x plus 1. That would have to be the top part, okay? So just a little bit of a thinking skill there on the that part. And then I'm going to pass out a worksheet for you to try.